Alright, so I believe that we're recording. Here in this problem, they're asking us to solve this equation. Well, we know that from past experience of solving equations, that the idea of solving an equation is to get the variable by itself, to eventually tell people that x equals whatever my answer is. Maybe it's 4, maybe it's negative 1/2, maybe it's the square root of 2. Well, here in this problem, my variable is not x, it's n, but the idea is the same. That step by step, I would like to get this n and eventually get it by itself to where I can tell you that n is equal to 0 or 1 or whatever number it is. All right, now in this packet, we're going to be solving two types of equations, exponential equations and logarithmic equations. Because my variable is an exponent, this is referred to as an exponential equation. And we have two types of exponential equations. Ones that we'll have to use this thing that's called logarithms, and one like this one where we can rewrite it with the same base. So all I have to do is think about how to rewrite the number 64 and how to rewrite the number 16 in such a way that it's some base raised to an exponent. So I look at 64 and I say, well, 64 is equal to 8 squared. I can rewrite 64 with a base of 8, but the problem is I can't rewrite 16. I could, but not with an integer value. That 8 to the first power is not 16, and 8 squared is already 64. So I really don't have an integer value that 8 raised to some power is 16. All right, so let's think again. Maybe think about this 16. How can I rewrite it? Well, I could rewrite 16 as 4 squared. I know that 4 squared is 16, and I can rewrite 64 as 4 to the third power. 4 times 4 times 4 is also 64. So just by playing around with mental arithmetic, I at least have a plan now to try and attack this equation. So this number 64, I'm going to rewrite it as 4 to the third power. And it's being multiplied times this number 16 raised to the 3n power. We say power or exponent. But I'm going to rewrite 16 as 4 squared. So you can see that these, well, they don't have the same base yet because this 3n has a base of 4 squared and this 3 has a base of 4. But it's getting closer, all right? Over here, this negative 3n minus 2 has a base of 16. Well, I'm going to rewrite this base as 4 squared. Well, now I have 4 to the third power. And when you have an exponent, we say that power raised to a power, that our properties of exponents that we learned way back when in Algebra 1 and Algebra 2 say that you multiply these exponents together. So this base of 4 now has an exponent of 6n. So this exponent 6n has a base of 4. This exponent of 3 has a base of 4. These two factors have the same base. That's what I'm working towards. Now I have this 2 and it's being raised to a power. So I multiply these exponents. And this 2 distributes to both of these terms. The 2 times the negative 3n is negative 6n. And 2 times the negative 2 is going to be a negative 4. All right. Now all of my factors here have a base of 4. See, before they didn't. So we're accomplishing something here. When I'm multiplying two values that have the same base, I can write that as a single base if I add the exponents. 3 plus 6n, only I'm going to write it just out of habit as 6n plus 3. The order in which we add numbers together doesn't matter, and that's called the commutative property. So now I've really accomplished something. I have the fact that these two numbers are equal to each other, even though they look different. And I also know that exponential functions are what they call one-to-one functions. That's going to allow me to say if these two numbers are the same and the bases are the same, it has to be that the exponents are the same. You know, if this 6n plus 3 represents the number 9, then this other one also has to 4 to the 9th power is equal to 4 to the 9th power. I know that whatever number 6n plus 3 represents, that negative 6n minus 4 represents the same number. I need to set these exponents equal to each other and solve this equation. So now we get the n by itself. We collect the variables on one side of the equation. I'm going to collect them on the left-hand side. And we collect all the numbers on the right-hand side. And we balance the equation along the way. I'm going to add 6n to both sides of the equation. 6n plus another 6n will give me 12n's. Now on the right-hand side, when I add 6n, it cancels with that term, and I just have negative 4. So on the left-hand side, I have my variable n, and on the right-hand side, I have just a number, and that's what I want. Well, this 3, that's just a number. I want to subtract 3 from both sides. That will get this n by itself, or the 12n by itself, because 3 minus 3 is 0. When I subtract to balance the equation, when I subtract 3 on the right-hand side, negative 4 minus 3 is a negative 7. Now on the left-hand side, I have two factors. I want to get this factor of n by itself. I want to undo this multiplication, so I'm going to divide both sides by the number 12. And it was just unfortunate. It doesn't really bother us that we can't reduce this fraction, and that our answer, it shouldn't bother us that this answer is a fraction. So there's my final answer, and I hope that helps, and I'll talk to you later.